Hello, my name is Anirudh Mohan. I'm in first period AP Chem, and I'll be explaining Hess's law, which is Unit 6.9, and how it helps us calculate enthalpy changes for reactions that are difficult to measure directly. Slide 2, the introduction. Hess's law states that the total enthalpy change of a reaction is independent of the pathway taken. This means that whether a reaction happens in one step or multiple steps, the total energy change remains the same. This is because enthalpy is called a state function, meaning it only depends on the initial and final states of the system, but not the processes that occur in between. Hess's law can also find the enthalpy changes for reactions that you can't measure directly, as explained prior. Slide 3, concept behind Hess's law. Why does Hess's law work? Because enthalpy is path independent. If we break a reaction to multiple steps, the total enthalpy change is just the sum of the enthalpy changes of each step. This is useful when we need to determine the delta H for reactions that can't be measured directly in a lab. Some rules for the Hess's law. Use these rules below to help manipulate steps in a reaction. So, if a reaction, if you want to reverse a reaction, you must flip the sign of delta H. So, if delta H was originally negative, then you would flip it to positive. And if it was originally positive, then you would flip it to negative. The second rule. If we multiply a reaction's coefficients, we must multiply delta H by the same factor. So, if, for example, the delta H was 2, for example, and you're multiplying the whole equation by 2, the new delta H would be 4. Similarly, in the third rule, if we divide a reaction's coefficients, we must divide delta H by the same factor. So if we're somehow dividing the coefficients of an equation, like for example by 2, and the delta H was originally like 4, then you would divide the delta H as well. So we'd get 4 divided by 2, which is equal to 2. The new delta H would be 2 in that case. Then if we add the reactions together, then we also have to add their delta H values. So now let's work on a practice problem. So find the delta H for C4H10O liquid into C4H8 gas plus H2O gas, given these steps. 4C solid plus 5S2 gas plus 1 half O2 gas is into C4H10O liquid with delta H negative 335 kilojoules per mole. The next step, 4C solid plus 4H2 gas is into C4H8 gas. Delta H is equal to negative 17 kilojoules per mole. Then the third step, H2 gas plus 1 half O2 gas is into H2O gas, and delta H is negative 242 kilojoules per mole. So what we're aiming to do is to combine all three of those substeps into the main reaction. So let's work it out. So uh, okay, so the first thing we should notice is that the C4H10O is on the left side. And which step has the C4H10O? The first step. So, and we want it on the left side. So what we're going to do is we're going to flip the first step backwards. So we're going to flip that equation backwards to get the C4H10O on the left side. So, but at the same time, we also need to flip the delta H sign as well from a negative 335 to a positive 335. So what we're going to do is flip the entire equation. So C4H10O into 4C plus 5H2 plus 1 half O2, and then the states, solid gas, and then CH4, and that's a liquid, and then delta H is what? Positive 335. So now we flip. So I'll write flip right here. Then next we'll look at the second one. So we notice that in the what we want is C4H8 and H2O on the product side. So let's look at our step. So our second step has C4H8 on the product side. And that is what we want. We want C4H8 on the product side. So and it has a correct coefficient as well, similar to the first step. But this time we don't have to reflect the equation. You don't have to flip the equation. So we can leave the second one as is and leave C4H8, the second step, alone. So we'll do 4C solid plus 4H2 gas is into C4H8. C4H8 gas. And then delta H is at negative 17. And then, okay. And then finally, we have H2 gas plus 1 half O2 gas is equal to H2O. And we want H2O on our product side and it has the correct coefficients. So similar to the second one, we don't have to do anything with this one either. And we can leave it as is since it's on the correct side as the original equation as a third step. So we don't have to do anything with that one. So we have H2 plus 1 half O2 is equal to H2 is into H2O gas. And the delta H we leave as is, which was negative 242. Then we just sum all of these equations. And what happens is that when we add all these equations, the same things on either side gets canceled. So when we're adding this, we end up having this, for example, this O2 gas and this O2 gas on the same side, on opposite sides with the same coefficients. So we cancel these out. This one remain C4H10O, I believe, stays on that side. Yes, it doesn't get canceled. These both get canceled. Uh, this remains here. This remains here, and then both of these combined becomes 5H2. This is 5H2. These get canceled, and we're left with what we want. C4H10O is equal to H2O plus C4H8 with all the correct states as well. Which is liquid. And yeah, and then now all we have to do is just sum the delta H values as well. What do we have? We have 335, then plus minus 17, then plus minus 242. So 335 minus 17 minus 242. So I get negative 76, and don't forget units, kilojoules, and that should be our answer. Yep, positive 76 kilojoules. So now on your own, uh, practice using the 5 problems I've posted. Hess's law is used in fuel combustion, photosynthesis, cellular respiration, explosions, and rocket propulsion. These methods use Hess's law to find the overall enthalpy change from smaller steps in between. Check out these videos if you would like to learn more. Thank you.